Binary agents return an English translated sentence of the past binary string. So JavaScript has a method, string.fromCharCode, which takes an ASCII coded number and returns that character. So, for example, A is 97, 96. We basically need. It's not necessary to know which code corresponds to each character. That is ridiculous nerd status that we can only aspire to much later on in life. But we do want to translate these binary numbers to actual base 10 numbers. And a few other things we want to do as well, so let's actually start by planning out what we are going to do. So the first thing, before we even think about translating, is we got this huge string and it's space separated, and we are going to translate each one of these into its characters. So the first thing we should do is break this into some data structure that allows us to iterate over each one of these groups of numbers. So we will say, the first thing we will do is translate structure into array. We obviously will use an array there. Then once we have that, we want to, let's say we'll translate binary to base 10. Then finally we will get the character from that base 10 number. So let's say get, and let me say, I should probably silence my phone, which is beeping at me right now. Okay, so we will get corresponding character using base 10. That's essentially what we're going to do. So translating the structure into an array, that's pretty easy. We've done this a few times before. We can just split it into an array, and we will pass a single spaced string so that we know that we are breaking this apart at each space. If we run that right now, you can see in our result we get a pretty fun pattern of the input in an array. So that's pretty easy. Next, we want to translate binary to base 10. We are basically parsing this int and making it into a number. Right now, remember, it's not only is it a binary number, but technically it is a string representing a binary number. There is a native JavaScript integer parser that we can use for this, but let's start off by making our own so we really understand the logic. It's a very good exercise to build our own binary parser. So this will be a helper function. I'll declare it down here. I'll call it Parse Binary, and it's going to take a string. So we basically want to get what each one of these bits represents as a number and add it to the final total. It helps, by the way, to, of course, know exactly how binary works. The first digit all the way, it goes from right to left. So the first digit over here represents the 0th power of 2, or the number 1. Then this represents the first power of 2, which is 2. Then we go to 4, 8, 16, 32, 64, 128. If it's 1, which is true, that means we add that power to the total. So that's, this is true for 1, so we have a 1. Then we get all the way over here. This is true for 64, so it's 1 plus 64. This binary string would be 65. So how do we write a function to actually figure this out? Well, since we are adding different numbers, we want to add it to some total variable. So let's declare that first. Start at 0, because if we get nothing, 0 is our base case. Then we're going to iterate through each one of these. We're starting it all the way at the end and going to the beginning. So we're going to declare a variable in a for loop, and we're going to set it to the length of the string minus 1, because when we access these, we are 0 indexed, so we subtract 1 to offset that correctly. Our condition I is greater than or equal to 0, and again we want the equal in there so that when we get to 0 here, we actually are accessing this and not leaving this out. So we want 0 to also be a true case for the for loop. And then we will decrement I, so we can go one at a time through the string of the binary. Now, we want to check if it is true, if there is a 1. So we have an if statement. If string position I is equal to 1, then we're going to do something. What are we going to do? We're dealing with powers here. So we're going to add, using the method from the math.pow is our math.power. And it takes two arguments like this. And it basically returns n to the power of m. It's always going to be a base 2 power, and it's to the power of 0, 1, 2, 3, etc. So how can we get that? Well, we could do something funny with, string.length and using our I to kind of switch around what the output is. So this would be 0 and this would be 1. It's a little complicated in here. So we can always and this is a nice little strategy to know, we can declare a second variable in this for loop. We can declare comment eliminated. We can declare, I'm just going to call it n equals 0. So now we have, in this first part of the for loop, this entire thing is now saying, okay, we are going to declare both I and n. I will be string.length minus 1, n will be 0. Then we have our condition, this is still the same, and just like what we had over here for declaring multiple variables, we can declare multiple operations to happen at each iteration, each pass of our for loop. So this will just be n++. Now we have a variable that starts at 0 here, and then goes to 1, 2, 3, all the way over to the n. What's nice about this is that now we have set up our logic in a way that we don't have to have a binary string of exactly the size. It can be smaller or larger, and this would parse the binary number correctly. So total plus equals math.pow 2 to the power of n. And then of course at the end we want to return our total. Great, so now we have a helper function. Let's chain this on here with a map function. If you don't know about these different array methods, I highly recommend the video on those. It's very great and useful methods to learn. So for map, it does take a function that it passes a number, its value of each, the value of each part of the array into it. We've usually done this with writing an anonymous function, but we can actually just add the entire parse binary method in here. It takes one argument, so this math function will grab this parse binary function, and it will invoke it, passing in each part of the array as its first argument, which will become this right here. So if we do that, and we test this now, as you can see, we get an array of base 10 numbers, which we will now use to get our actual English characters. Now that we have our base 10 numbers, we can proceed to translating them. So, we have this array here. Remember, this is the current state that we are working with. We have this method here, string.fromCharCode. If we click on this, we see here that it requires one argument, but it can take any number of arguments. This is code for these are optional arguments, and this goes all the way to num_n, which can be whatever we want. And the example here shows that if we pass in multiple arguments, then we get the correct characters back, which is really nice. It looks like 65 was ASCII for A and not 67, as I had mentioned before. Good lesson for me. So if we go back here, I would just love to pass all these arguments in at once, but they are currently in an array. Well, there is a great method called apply that can invoke a different method or function, and you can pass in an array, and JavaScript will take that array, and each index in the array, it will invoke the chained function as that argument. It's really, really useful for something like this. So instead of doing string dot from char code and adding something in there, we're going to do string dot from char code dot apply. And the first argument is what will be used for the this identifier. That does not apply to what we're doing here. We are not making use of that, so I can just put null here. That's fine for me. And then we want the array, which will be used as all the arguments. So the array, which is currently, well, actually, I'm just going to change this here for best practices in readability, since this is technically an array right now. We'll pass in now this r variable, which will be the array of arguments, these different strings, these different numbers that we want. So it's going to take this one here, and it will output the number A. And I'll take this one here, and it will output, well, we know, ideally, we're hoping it will output the number R. We will have to test this, of course, to make sure it works. So we have that. We are now going to assign that, transform our R variable to be what this outputs. And what this will output is the actual, ideally the actual result. Let's run the test. It looks like it did. Hodor! Haha. That's great. So I'm just going to real quickly make this a little bit cleaner. And if we assign it here, it's not really an array anymore. We're just going to return this actual result. It's the exact same thing. We run it, it still works. Finally, I want to show you, as promised, the JavaScript way of parsing an integer. It involves this, let me get rid of these comments here. It involves a function, parse int. This function is always available. And what parse int does is it takes a number that's in a string and it translates it to the actual number type. So I will just return this for a second. This will short circuit here as it's showing an unreachable return, just to demonstrate what it does. So this is a string. It's now, there's no quotes around it. It's now 24. The interesting thing about this is you can declare a second argument that tells JavaScript this is the base that this number is in. So if we made this, a base 6 and run the test, it would translate it to something different. I don't know what base 6 would be off the top of my head, but we do know that binary is base 2. So if we did something like this, 10, like the number of people there are in the world, those who understand binary and those who don't, 10 translates to, of course, 2. There's a 0 for the 1 part, a 1 for the 2. It becomes 2 plus 0, which is 2. So if we have this binary string and let JavaScript know that it is base 2, that it is binary, and run it, it translates that correctly. So that means we can actually get rid of that completely, our helper function, and we can just do this. Array equals, well, not there, whoops, forgot what I was doing for a second. We can just do, in this map, instead of our parse binary function, we can make an anonymous function. It will take a number, one of the digits, and we will just return parse int of that digit and let JavaScript know it is in base 2. This does all the work that we essentially have written ourselves. So now our function is a lot smaller and does not require any other helper functions. We run the tests and we get a pass just like we did in our homemade binary parser. Hope that was helpful, and if not, you know what to do. Please leave a comment, and we will continue our JavaScript journey.